Hello, welcome. We are live at the launch pad here at the Guiana Space Centre for the 5th launch this year. Our passenger today, SES-15, is a geostationary communications satellite for SES and built by the guys and girls at Boeing. I'm in the Mission Control Centre here, Jupiter, 20 kilometres from that pad, roughly as the crow flies. And the launch is going through its final preparations for liftoff. That's scheduled in just under 14 minutes' time. You can see the countdown clock there on the top right-hand side of your screen. So we are flying on board Soyuz today. This is actually the second time that Soyuz will have carried a geostationary satellite from the equator. Soyuz stands 46 meters high and weighs 388 tons. And sitting on top of the launcher inside the fairing is our passenger SES-15 for the operator SES, with a launch mass of 2.3 tons. Now, ladies and gentlemen, that's very light for a geostationary satellite. Normally they weigh in at around about 5 tons, this is because SES-15 is an electric satellite, SES's first one. All this makes today's a slightly different mission.
The liftoff of the 17th Soyuz will occur from the Guiana Space Center.
The target orbit is a sub-GEO. After the standard Soyuz 3 stages ascent phase, 2 frigate boosts will be necessary to reach this orbit. One close to the perigee and one close to the apogee, with a long ballistic phase of 4 hours 33 minutes in between.
For this mission, the ground stations network includes Galileo, the French Guiana station, Natal in Brazil, Ascension, a British island in Atlantic Ocean, 2 African stations, Libreville in Gabon and Malindi in Kenya, and finally New Norcia in Australia. Those stations allow us to follow the whole flight. No loss of visibility is foreseen.
The separation will occur 5 hours 18 minutes after the liftoff. After that, a last frigate boost increases the inclination of the frigate end-of-flight orbit. The total mission will last 7 hours and 4 minutes.
Data collected by the stations are sent in real time to the CDLS, the Soyuz Control Center in French Guiana, and to Moscow in the Frigate Flight Center monitoring. Claude Legrand is our technical representative in Moscow for this flight. At the end of the mission, she will be in charge to deliver the orbital diagnosis to the management in Jupiter to confirm the correct separation conditions of SES-15 and their final orbital position.
Arianespace is going to launch the US Boeing-built satellite for SES, the European operator, with Soyuz, the mythical Russian launcher. Arianespace always offers the best solution for any of its customers.
So, a long journey ahead today, and on the right of your screen, those are the status panels which are displayed here in the Mission Control Centre. They are showing us the health of 3 main systems across the base: the rocket and the pad, the satellites and the range. You can see them there. That's what everybody is looking at here in the Mission Control Centre. Now, we are coming up to an important milestone.
Attention pour I0 moins 10 minutes, 20 secondes.
There's the Range Operations Manager Raymond Boyce about to announce it.
Top, début de la séquence finale, lanceur.
And he has announced the beginning of the final synchronized sequence for the frigate upper stage, the last 10 minutes. It's sent the signal to say that it's ready for flight, and the computers are now running the final checks. They have a lot of operations to deal with during this time. So we are 9 minutes and 45, 46, 47 seconds to launch and counting down. SES is getting closer to its liftoff time, getting closer to starting its journey to its geostationary orbit, which is, of course, 36,000 kilometers above the Earth. Let's find out more about today's mission and go over to the CEO of Arianespace.
Dear customers and partners, ladies and gentlemen, Arianespace is delighted to welcome you at the Guiana Space Center for this new Soyuz mission. For the second time this year, our medium-weight vehicle is about to perform a GTO launch from the CSG. It will put onto orbit the first full electric telecommunications satellite, SES-15, for our close customer, the European operator SES. The payload has been built by our long-standing partner, Boeing. Thanks to SES for your trust. Soyuz is now on the launch pad. The operations linked to the final countdown are in progress. The launch is imminent. Following liftoff, Soyuz will head towards the east to separate the satellite on an elliptical orbit inclined at 6 degrees with respect to the equatorial plane. Due to the electric propulsion of the spacecraft, the mission is a long one. After a first burn of frigate and a long subsequent ballistic phase, SES-15 will separate around 5 hours and 30 minutes after liftoff. But let's leave this launch together. Go Soyuz, go SES-15, and of course, enjoy the show.
So, Stéphane Israel there, ladies and gentlemen, the CEO of Arianespace. Now, we have a number of different operational teams working here in the Mission Control Center, often known as Jupiter, rather fondly by the locals here. This is the Flight Directorate, or the Flight Desk. These are Arianespace top management, and they take all the final decisions in the case of unplanned situations. And of course, we have joint Russian and European teams sitting shoulder to shoulder here. Now, the other control center is the Launch Control Center, and that's about 1 kilometer from the launch zone in a specially protected building. It's called the Soyuz Launch Center. We have various teams working in here. One is responsible for the ground operations. They are led by the launch site operations managers. And again, we have Russian and European teams working side by side. And another team is responsible for the flight readiness of the launch vehicle, of the Soyuz today, and that's led by the production managers. And of course we have very strict procedures, all of which have to be adhered to. Everyone concentrating hard at this point now as we get closer and closer to the launch. Some of the other teams here working in the Mission Control Center. This is the Program Director for Arianespace, the Program Director's desk, in charge of the contract for Arianespace. And the Satellite Mission Directors are in charge of preparing the satellites for SES, Arianespace's customer. And they have the job of confirming when the satellite's ready for launch, and they communicate with their control center, who are the people who will be actually flying the satellite. Of course, all of these men and women work very closely together during the launch campaign. Let's find out what everyone's been doing to prepare for today.
Talking about a launch campaign, you talk about two different campaigns, the satellite campaign and the launcher campaign. Each team works alone to begin with, and then they work together during the combined operation plan called the POC.
The launch campaign Soyuz VS17 began February 1st with operation on the upper stage frigate in the MiG building. In parallel, in the MiG, the three-stage was horizontally assembled. First, the two half sections on the central core. Then, around the central core, the four boosters were integrated, giving to the launcher its familiar shape. Finally, the third stage was linked to the main core. This part is easily noticeable due to the lattice beam. After 3 weeks preparation, frigate was transferred to the F-Cube, the frigate fueling facility.
For this VS17 preparation campaign, SES-15 is the first satellite to be launched from the CSG using an electrical propulsion. Preparation was shorter than usual, as no fueling operations were required. We only used electrical checks, which were successfully carried out. The combined operations began at day -9 with the strapping of the satellite on the flight adapter. SES-15 was then transferred to the F3B building at day -8. Frigate arrived at day -7 and SES-15 was integrated at day -6. The nose fairing covered frigate at SES-15.
D-3 is a day where I transfer the 3-stage and the upper composite on the launch pad. Early morning, the 3-stage is put on vertical position thanks to the carts. By the end of afternoon, after 1 hour and 30 minutes trip from S3B, the upper composite reached the pad. Then, hoisted in the mobile gantry at the level 27 meters, and finally assembled to the 3-stage.
The 2 other days were used for dress rehearsals and final verifications before the final countdown.
And on day 0, the tanks are filled. After a synchronized sequence of T0 minus 20 seconds, the engines are ignited and the liftoff occurs.
So that's what's been happening so far, and here we are today now at 2 minutes and 51 seconds to the scheduled liftoff time. I'm in my commentary box now in the Mission Control Center, and it's a surprisingly beautiful day out there. It's been extremely wet and rainy, but it does not seem to be raining quite so much now. So the frigate upper stage started its countdown, synchronized countdown, and now we have also had the beginning of the final sequence for the main vehicle. Look at that big mast. It's called the KZM, carrying the umbilical lines to the upper composite, the upper part of the launcher containing the satellite. That's going to pull away just before launch. Those lines have been disconnected now. There's a smaller mast underneath it. You can just see it on the right-hand side. That will pull away just afterwards. A word about the ignition sequence. On Soyuz, there is a system for checking the health of the engines before it leaves the pad. We throttle the engines up over a period of 17 seconds, 16 in this case, just to make sure they're working well. And once they've been throttled up, the engine leaves the pad. Nothing can hold it back. Coming up to the 1 minute mark.
À tout de DDO, attention pour moins 1 minute. Top I0 moins 1 minute.
We are 1 minute to launch. We are live at the Guiana Space Center, and we're launching SES-15, the European operator's first all-electric satellite built by Boeing. And we're travelling on board the 17th Soyuz to launch from the Amazonian jungle. Our best wishes to all the teams.
Largage du mât KZM. À tout de DDO, attention pour le début de la séquence d'allumage du lanceur. Top I0 moins 20 secondes. Largage du mât VKM. Allumage triétage. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Décollage. Liftoff. Sont normaux. initialisation du lanceur. Paramètres propulsifs sont normaux.
And they
Vol nominal.
are off. SES-15 has begun its long journey. Raymond Boyce, the range operations manager, is telling us that
Paramètres
everything
nominaux.
is going according to plan. Les paramètres sont nominaux. Everything's normal. We're heading east. That's unusual for Soyuz. Normally it goes north. We're going east today because we're carrying a satellite headed to geostationary orbit.
Propulsion premier et deuxième étage, nominal.
I was rather hoping that we were going to see the boosters fall away there, but we just lost the launcher, and we are coming up now to the scheduled moment when we jettison the boosters. Look at those super images from cameras mounted on a previous launch. They are twisting and turning. It's all part of the plan.
Extinction des moteurs du premier étage, séparation des boosters, AVGD.
That's all been confirmed now. So we're burning the main core stage. It's going to burn for about 3 more minutes. And we're looking here on the top right-hand side of the screen. You can see our trajectory. That's the planned trajectory, and the cross is the actual position of the launch vehicle. Bottom left is our altitude, 81 kilometers above the Earth and climbing. We're heading towards the Kármán line. That's the border between space and our atmosphere. It's where the atmosphere
Vol
becomes
nominal, trajectoire nominale.
so thin that it can no longer support vehicles with wings. So it's where aeronautics ends and astronautics begins. Look at the top of the vehicle, the nose. That's called the fairing. The satellite is inside there.
Paramètres de structure du lanceur sont nominaux.
And it's been protecting the satellite from the rigors of the launch so far. So from the acoustic vibrations at liftoff, it's very loud, you can just imagine. And also from friction, because we have been travelling through the dense part of the atmosphere. But now the atmosphere is so thin that we don't need it anymore. It's able to be jettisoned.
Séparation coiffe.
And that separation of the fairings been confirmed. So we can see our satellite for the very first time. The captain has switched off the seatbelt signs. There it is on the right-hand side. The rectangles are the solar panels. Of course, right now it's all folded
Paramètres
up.
propulsifs nominaux.
And later, once it's been released, it's going to open its wings like a butterfly. And the gold structure, if you look on the right-hand side of the screen, is the frigate upper stage. And the satellite is attached using a very special and clever dispenser. Bottom of the screen, our distance from the pad, 432 kilometers. That's if you were to draw a straight line along the Earth from the pad. This is the scheduled separation now of the second stage and ignition of the third stage. Those
Allumage du
parts,
troisième étage, bloc I, extinction du deuxième étage, bloc A, séparation, bloc A.
and he's confirmed that. Soyuz has what's called, or uses rather, a hot stage technique, which means that
Largage de la section arrière du troisième étage, bloc I.
it switches on the third stage engine before switching off the second stage. A word about our confirmations. We're seeing the key moments happening at the planned time. We get our actual confirmations
Paramètres de structure du lanceur sont nominaux.
of those milestones just fractionally later. That's perfectly normal. That's because it takes the information a little bit of time to get to the range operations manager here at the Guiana Space Center from the launcher, and that's because it goes via Moscow, where it's validated before coming to the launch control center here at the CSG being the Guiana Space Center.
Trajectoire nominale.
He's telling us that everything is going nominally. Our speed on the bottom right-hand side of your screen, 4.63 kilometers per second. And we left the pad from the northeastern corner of South America. Galileo there on the left-hand side is the tracking station here at the CSG. We lifted off 6 minutes and 46 seconds ago from the pad.
Par la station de Natal au Brésil.
And he's telling us that we have now picked up the signal at the Natal tracking station. You can see it there. It's on the northeastern coast of Brazil. We're tracking the launcher using the ground stations. Oh, look at that superb replay. We were very lucky to have such a beautiful view of the launch because it has been raining a lot recently. It's been raining cats and dogs, to be honest.
Des moteurs du 3e étage, nominal.
And today we got super blue skies. These images we're looking at are CGI images, computer generated. They're showing us exactly what the experts have calculated is happening to the launcher and the satellite. So basically what happens is the teams plan a very precise schedule of events based on extremely accurate predictions, and they put all of that information into the computer, and these images are a simulation of those predictions. So basically every movement, every position, every twist, every turn, every flash of an engine that you see is based exactly on what has been planned for this flight.
Vol nominal.
Everything's going normally. Our altitude 200 kilometers. We're traveling at coming up to nearly 7 kilometers a second. The third stage is now shutting down its engine and separating from the frigate upper stage. That's what it looks like as it is jettisoned, and we are now starting the next phase. The frigate upper stage is in what's called the pre-burn phase. It's getting ready to switch its engine on. That takes it 55 seconds.
Section du 3e étage, bloc I, séparation de l'étage frégate et du satellite SES-15.
Now we have confirmation of those events. So what frigate does is it gives a quick burst of acceleration, and that pushes the fluids back into the tanks. So it's a little bit like when you put your foot down on the accelerator in your car and you get pinned back against the seat. And the frigate upper stage is switching its engine on now. So we're really beginning the next part of the journey. The main propulsion phase is over, and frigate is our taxi driver. Its job is to deliver our satellite to its drop-off point in space. We call that the separation orbit. So frigate, the gold structure on the right-hand side and the satellite to the left of it with the rectangular panels there. Frigate has 6 spherical tanks organised in a circle. You can just see it on the right of the screen. 4 of those tanks.
Confirmation de l'allumage de l'étage frégate.
4 of those tanks are for propellant and 2 for avionics, which you normally find in the cockpit of a plane. Frigate was originally designed as an interplanetary probe to travel around in the solar system, and then it was adapted to fly on Soyuz. It can actually switch its engine on and off up to 20 times, and that means that it can take its passengers pretty well anywhere they need to go. So that makes Soyuz ideal for launching all kinds of spacecraft, and particularly useful for constellations. Today, it's going to use its engine twice to push SES-15 to its drop-off point in space, to its separation orbit. Our altitude, 186 kilometres. Our distance from the pad, well, we've travelled nearly 3,000 kilometres in a straight line across the ground. And we're travelling at over 7 metres a second now. The teams at Boeing built SES-15 at their factory in El Segundo in California, using their 702 SP series of platforms, SP meaning small payload. And this is the 53rd Boeing satellite that Arianespace has launched, but it's the first time they've carried a satellite in the 702 SP series. Arianespace actually has 4 other Boeing satellites in the order book. So, SES-15 is SES's first all-electric satellite. And it's also their first hybrid payload, so it's packed full of innovative technologies.
La visibilité de la télémédière par la station de Natal.
SES-15 is our hybrid satellite, and by hybrid I mean that the payload actually has 2 distinct parts. It has a wide beam element for broadcast and broadband distribution type of services, and it has an HDS element, which is really for our data service and for our aero mobility type of services as well.
The main sectors that will benefit from SES-15 are the aeronautical sector, the maritime sector. We are also going to provide services to highly intensive data applications such as governmental networks and enterprise networks.
Because it's a completely electrical satellite, the orbit raising is relatively slow. SES-15 is only around about 2.3 tons, but from volume and capability, it's an 8 kilowatt satellite, and the amount of payload that we can carry, because we don't have to carry so much fuel, is extreme. So it's a very, very cost-effective satellite for us. It offers huge capability into the marketplace, and this is actually the very first all-electric satellite that SES has ever launched. So it's electric propulsion for the orbit raising, and it's electrical propulsion for the subsequent station keeping. So all electric.
3, 2, 1, fire!
We are actually tailoring and specifically designing those beams to have more capacity where more demand is needed. For instance, on the regions from Washington to New York, that's where you have the most intensive aeronautical traffic. We also have a hosted payload called the WAS, the Wide Area Augmentation System. And this is going to be used by the FAA to improve the accuracy and the reliability of GPS-based navigation.
It's the first time that we've used Soyuz for a geostationary satellite for SES. Of course, the O3B satellites were both launched on the Soyuz launch vehicle, but for the GEO world, this is the first time we've launched it. This is only the second GEO mission that Soyuz has run. It's a superb vehicle. It's very exciting, and we can't wait to get ahead with this launch and to move on with the mission.
So an exciting day for everybody here, an important satellite, and we are now flying out across the Atlantic. We've got halfway across. We're using the tracking station in Ascension Island to follow us. That's a volcanic outcrop in the middle of the Atlantic. Used to be a stopover during the early days of commercial airlines. So the trend for electric satellites is growing, there's no question about that. Already 15% of satellites in Arianespace's order book
système
are
bord
electric.
fonctionne nominalement, le moteur frégate fonctionne nominalement.
Everything's going normally. And it's predicted that by the 2020s, half the world's satellites will be powered by electric motors. Now, this type of propulsion means that you don't have to carry propellant, because the engine gets its power from the solar panels. So there's lots of pluses to that. It means that you can save on mass. And that's why this satellite is lighter than normal. And you can make satellites that are just as powerful, but half the weight. In space, where every gram counts, that's a big saving. And it gives you the opportunity to embark more services on board as well. So that's why Soyuz is able to carry SES-15 on this mission. A normal geostationary satellite would be too heavy for Soyuz, probably about 5 tons. Soyuz can accommodate a geostationary satellite up to just over 3 tons. And SES-15, of course, is only 2.3. So it's light enough for Soyuz to be able to launch it. You can see Ascension Island, the tracking station in the middle of the Atlantic. We're heading towards the west coast of Africa. The next one to pick us up will be Libreville. That's the acquisition there. This is the second time rather, that Soyuz has launched a geostationary satellite from the equator. Now we have confirmation of the Libreville tracking station acquisition of signal. The first one was Hispasat 36W1. That was the end of January. That was a 3.2-ton satellite. Now, all these kinds of campaigns create strong bonds between people and long-term friendships. Teams have to work closely together, solving problems and having some fun at the same time. Let's find out about the fruitful relationship with SES.
The time required for this transfer from GTO to its circular orbit at 36,000 kilometers altitude is somewhat longer than for satellites using chemical propulsion. Thanks to the performance of the Soyuz vehicle, we have been able to optimize the delivery orbit, hence reducing by 1 month the time to reach a GEO. So we are here today with Thiago Consor, the SES-15 spacecraft Deputy Mission Director. So Thiago, can you tell us a few words about the spacecraft mission?
Yeah, so SES-15 is going to be operated from 129 west orbital position. It's going to cover North America, Central America, and the Caribbean. And what is special about SES-15 is it has 2 missions, right? 2 specific missions. It's a hybrid payload. It's the first hybrid payload to join SES family. And it's composed of 1 wide beam coverage that's going to provide, for instance, broadcasting of TV channels. And it also has a 1 HTS mission that will provide high-speed internet for mobility applications. In addition, we also have a hosted payload. We have the WAS, which is going to be operated by the FAA to improve reliability and safety of air traffic control.
And can you tell us a few words about what's going to happen after the separation?
After separation, we are going to turn on all the telemetry transmitters by an automatic sequence, and this will basically allow us to make first contact with the spacecraft. We're going to start receiving telemetries from all subsystems and make sure they are in good health. After that, we're going to release and deploy the reflectors, release and deploy the solar array wings, and we are going to initialize the electric propulsion subsystem for transfer orbit. SES-15 then will start its ascent to geosynchronous altitude.
Thanks very much, Thiago.
"20 minutes into the flight, coming up to 21 minutes. As we heard from Martin Halliwell earlier, the electric motors give a much weaker thrust than engines powered with propellant. So they do take longer to get to their destination, and for a geostationary satellite, that's 36,000 kilometers high, of course, 22,000 miles. So to help with this, the frigate upper stage is going much deeper into space than usual today. Normally, we release fuel-powered geostationary satellites around 2,000 kilometers above the Earth on average. So they have to travel the remaining 34,000 kilometers on their own. Usually that takes them some days. But today we are taking our satellite virtually all the way there and dropping it off at an altitude of 31,300 kilometers. So that means that it's only going to have to travel 5,000 kilometers on its own. Even so, it's still going to take it, I believe, around about 7 months to do that. So Arianespace came up with a solution for shortening that journey along with the SES and the teams and Boeing. SES-15 will be on an elliptical transfer orbit. An elliptical orbit is an orbit which is shaped like an egg. And the frigate upper stage is going to release SES-15 at the top of that elliptical orbit, where the spacecraft is closest to its final destination. So imagine at the top of the egg. So because of all this, we have a longer journey today. We will be having a coasting phase coming up, which will last about 4 hours and 30 minutes. And it's going to take us a total of 5 hours and 18 minutes from liftoff to deliver our satellite to its separation orbit. And he's confirming there that we have now picked up the signal at the Malindi tracking station, Malindi being on the east coast of Africa. If you look at the top right-hand side, you can see we're really climbing into space now. Our altitude on the bottom left, 519 kilometers above our planet. The frigate upper stage is getting ready to switch off its engine. It reduces its thrust slowly. Engines prefer to run down remaining fuel at a reduced power because it's steadier. Travelling at over 9 kilometers per second. We are now entering the first ballistic phase. Ballistic, of course, means without propulsion. There you can see the path that we have flown across the Earth. And there's the Malindi tracking station there on the east coast of Africa.
Extinction du moteur frégate.
And we have confirmation there that the frigate upper stage has switched off its engine. So yes, ballistic means without propulsion, so we are travelling high enough and fast enough to cruise without the engine. This ballistic phase is going to last 4 hours, roughly 4.5 hours. And that was our super launch nearly 25 minutes ago from the pad here at the Guiana Space Center. We're going to take a break during this coast phase and come back to you 8 minutes before separation of the satellite. I'm going to read out some times for you. So, local time here in Kourou, we will be coming back at just before 2:05 this afternoon. a few seconds before 2:05. That is 5 o'clock in the afternoon, late afternoon, Universal Time. 6 o'clock Luxembourg time, 7 o'clock in the evening Moscow time, and 12 o'clock midday Los Angeles. We shall see you again shortly. Bye for now. Hello again. Welcome back. We are 5 hours and 10 minutes into the launch of SES-15. I'm Katie Haswell, and I'm coming to you live from Mission Control here at the Guiana Space Center on the northeastern edge of the Amazon rainforest. Right now, SES-15 is hurtling through space, riding bareback on the frigate upper stage. That's what's left of the Soyuz launcher. We had a long coast phase which lasted 4.5 hours. Then the frigate upper stage switched its engine on very briefly to get us onto the right orbit. And here we are again now. We came off air during that coast phase because it was a long time. And here we are again now, picking up our program 7 minutes now to separation. And that's the voice there of the Range Operations Manager, Raymond Boyce today. So SES-15 is a geostationary communications satellite. It's the first all-electric satellite for SES, the first one of two actually. And it was built by Boeing at their plant in El Segundo, California, using their 702 SP series of platforms. SP means small payload. So right now we are over 31,000 kilometers above our planet, but 5 hours and nearly 12 minutes ago, we lifted off from the pad here at the Guiana Space Center. Travelling on board a Soyuz launch vehicle, and we were incredibly lucky because it's been raining solidly for the last few days, but the sun came out just when we needed it and gave us some beautiful clear skies so that we were able to see the launch very clearly. We saw pretty well the first 2 minutes with the naked eye. Then the boosters fell away and were jettisoned. Then the fairing at 3 minutes and 40. The second stage, we ignited the third stage. And then when that switched off its engine, the frigate upper stage took the wheel and has been transporting our satellite ever since. We had a long coast phase when the frigate upper stage switched its engine off, and it had a quick blast of switching it on again just to get us onto the right orbit. Now that orbit is elliptical. That means it's the shape of an oval or the shape of an egg. And if you take a look at our speeds and our altitudes at the bottom of the screen, we're travelling, our altitude on the bottom left, we are nearly 32,000 kilometres high, but we're travelling, and we'll see the speed again in a second, at 0.82 kilometres per second. So we've actually slowed right down, because before we were travelling at nearly over 9 kilometres a second at one stage. And the reason that we are slowing down is because SES-15 is an all-electric satellite. That's great news in terms of mass because it makes it half the weight of a traditional geostationary satellite. But it does mean that the engines, which use solar power rather than traditional propellant, take a lot longer to push us to the orbit, to the final orbit, because they use a weak thrust. So SES-15 is going to take about 7 months to get to its final orbit once we drop it off at just over 31,000 kilometers above our planet. So right now we are tracking all of these movements from the new Nausea tracking station. And the teams who are monitoring all of this and watching over these operations are the teams at the CVI. That means Immediate Visual Control. They're based here in the Soyuz Launch Control Center, which is very close to the pad. And these guys and girls are receiving the information from the tracking stations, which gets sent also to the frigate flight monitoring center in Moscow, where it's validated before coming back here so that the range operations manager can then call out all the key moments during the flight. So this means that the teams are able to monitor the flight in real time, and they can also analyze the data after the event in order to check how things went. If you look at the bottom of the screen in the middle, you can see that we've traveled a distance of nearly 18,000 kilometers if you were to draw a line across the planet. But of course, as I was explaining, because we are on an elliptical orbit, an egg-shaped orbit, we are really climbing high, deep into space. Separation scheduled in 2 minutes' time. This phase is often known as the space ballet, and that's because the spacecraft is going through a series of very, very carefully planned maneuvers. We have 4 orientation maneuvers during this sequence. We've already completed 3 of them, and the 4th one is coming up shortly in probably about 10 to 15 seconds. We have a separation altitude of 31,074 kilometers, if I'm correct, and a separation speed of 0.83 kilometers per second. That's still 3,000 miles an hour. Still fast. And we separate the satellite using a set of springs, which effectively ping the satellite into space. It's almost like a slingshot. If you were to take a sling and sling a stone into space fast enough and high enough, it would stay up and keep going. And this is the scheduled moment for separation of SES-15. And we wait, of course, for the confirmation from the range operations manager. Don't forget that information has to be validated in Moscow before it can be confirmed here. Very high levels of concentration at this point during every launch and every separation. You can see the top of that orbit there.
SES-15.
And we have separation of SES-15 has been confirmed. Soyuz and frigate have successfully delivered their 42nd satellite launched from the CSG. Some happy faces there. And some very well-deserved slaps on the back. Everyone's worked extremely hard to bring us to today, and this has been a very successful mission. Flawless. So now the satellite is separated, the operational teams at SES who fly the spacecraft are swinging into action. And right now the concentration levels there will be extremely high. They've taken charge of their bird. They have a range of post-separation activities, namely the first acquisition of signal from the satellite to make sure that it's healthy and calling home. And then 5 days after separation, SES-15 starts deploying its solar panels to generate power. And here we go, we lifted off from the pad 5 hours and over 20 minutes ago on the Soyuz STA version. The weather was kind to us. We had beautiful blue skies and a super view of the launch. So this is the second Soyuz to lift off from the pad here at the CSG this year. 2017 is certainly a busy year. 12 launches all scheduled, 7 of those Ariane 5s, the 2 Soyuz who've already lifted off, and 3 Vegas. So we've already had 5 of those, and the schedule for the rest of the year remains unchanged. May and June are going to be particularly busy for the teams here because, or are particularly busy because they are dealing with 4 launches in 2 months. And they will have had 7 launches in the first half of the year. That's quite an achievement. We're waiting now for the official speeches. Frigate, of course, has now delivered the satellite, but its job isn't done. We have what we call a passivation phase to go through. We have to put Frigate into its graveyard orbit. We have to empty its tanks, empty the propellant, and then it has to make its way to its final orbit. So it'll be using its engine again to do that. And then it'll fall back to Earth and burn up in the atmosphere. Waiting now for the official speeches as the various speakers make their way from what we call the fishbowl to the floor. The fishbowl is the area behind the glass where all the mission controllers sit. And we have a number of operational teams in there. And of course right now we're looking at the VIPs who are facing that fishbowl, the glass area, the operational area if you like. The Guiana Space Center is a pretty big place. In fact, it's about the size of the island of Martinique, and that's about 750 square kilometers. And it's called the range, but the range doesn't just cover the space center here in French Guiana. It also includes all those ground stations that we saw during the flight, in this case dotted along the equator. And all the facilities, the preparation facilities for the satellites, the launch zones. Don't forget we launch 3 rockets from here. We have the Ariane 5 big heavy lifter, and we have Soyuz the lightweight, the middle lifter, and Vega the lightweight. Still waiting for the official speeches and some discussions going on. And so the range is, as I said, it's a pretty big place. And you can just imagine the logistics of connecting everybody in the range and everybody being able to communicate with each other. Which is why we have the range operations manager to call out all the important milestones. So we have confirmation of the separation of the satellite, and we are now waiting for the acquisition of signal confirmation from the ground station in Korea. It's called commune. And of course that first acquisition, once we get the information from that, gives us information about the satellite. So that was 5.5 hours ago. It's been a long journey for SES-15. Right now, we are looking at that launch pad 5.5 hours later. This is the gantry, and that's now been closed. And you can see the towers surrounding it, which are for lightning conductors. Still relatively clear skies here. It's actually been a very beautiful day. It was wet and raining for about 3 days in a row. It's not called the Amazon rainforest for nothing. You can see the vegetation there. The Soyuz pad is in Sinnamary, which is about 20 kilometers from the Mission Control Center as the crow flies, but if you're driving it's going to be a little bit longer. And this is a launch zone that was built specifically in order to be able to launch Soyuz from here at the Guiana Space Center, because of course Soyuz is a Russian launcher which has launched traditionally from the Baikonur Cosmodrome in Kazakhstan and still launches from there. So we have launches from Baikonur and also from the CSG. Soyuz is a very reliable and efficient launcher, and it's been the workhorse of the Soviet-Russian space program since 1966. And right now, of course, it's the only manned vehicle. So it looks like we have some good news there, and confirmation that the satellite is in a healthy state.
Ladies and gentlemen, distinguished guests, Arianespace is delighted to announce that SES-15 has been separated as planned on the targeted sub-geostationary transfer orbit. For our 5th launch of the year and the 17th Soyuz since its introduction in the European Spaceport, our medium-weight vehicle performed flawlessly. Congratulations to all. The passenger for this flight, SES-15, is the 40th geosatellite launched by Arianespace for the European operator SES since 1984. Doing so, more than 40% of SES geosatellites currently in operation have been orbited by Arianespace. This is not to mention all O3b network satellites now in NEO orbit. Moreover, it is our pride to have put onto orbit SES first all-electric telecommunication satellites. We have 5 more SES satellites in our backlog, including another electric satellite SES-12 and 4 additional O3b spacecraft. So let me express my sincere gratitude to CTO Martin Halliwell, who honors us with his presence and his smile today. Thank you, and see you very soon in French Guiana again. Congratulations also to our long-standing partner, Boeing, who built the spacecraft aboard this flight. SES-15 is the first geosatellite based on the all-electric 702 SP platform in California that is launched by Arianespace. Now, with 53 Boeing-produced satellites orbited since 1985 by Arianespace, and 4 more coming soon in our backlog, we will certainly continue to partner for many common successes. So many thanks to Boeing for your trust, and more specifically to you, Mark Spivak, who is with us for this launch. Thank you very much. Ladies and gentlemen, this 5th flight of the year is also the 2nd mission to GTO with Soyuz from the CSG, and the first ever embarking an all-electric satellite. This demonstrates one more time the availability and flexibility of Arianespace launch vehicle family, adapted to any type of mission at the service of our customers. I would like to express my gratitude to our Russian partners, Roscosmos, RKC Progress, NPO Lavochkin, and Sanki for their cooperation. Well done to all of you. Spasiba bolshoy. Let me congratulate also the European teams who, alongside our Russian partners, have greatly contributed to today's success. Our ground contractors here in French Guiana and our daily partner, the CNES CSG team. Last but not least, let me pay my tribute to my Arianespace colleagues for this latest success and their outstanding professionalism and commitment to our customers. And if you allow me, I would like to address special thanks to François Barrault, who pushed for this long-lasting mission. Hats off to him and the mission analysis teams in Russia and Europe. A few hours more of coastal phase for sure, but it will give you a few weeks less to orbit. So it was worth it. Thanks to all. I now would like to welcome to the stage our customers and partners. Martin?
Thank you very much, Luce. Okay, so Luce has said most of the things I was going to say, but yeah, that was our 40th satellite. We're going to be back for more. We just have acquisition of telemetry, so that's good. The spacecraft is looking healthy, and the mission is progressing perfectly. So absolutely fantastic, and thank you very much for that. I'd just like to thank all of our various different partners on this particular mission, all our industrial partners. Arianespace, now known as Ariane Group. Okay, I read the press release. Roscosmos, CNES, and Boeing, of course, our good friends here. But most of all, I would like to thank all of my SES colleagues, some of whom are down here in the bullpen, and many more are working on our various different sites all over the world. So thank you very much for all the efforts that you've made during the procurement phase of this. We're heading for service by the end of December. We're heading towards 129 degrees west. And we're looking we're very excited. We're looking forward to welcoming all of our customers, many of whom are here today, to come on board and continue with the services in our aero and maritime mobility, and of course with our WAS hosted payload as well. As Luce says, we're going to be back again. I hope we're going to be back again this year. Florent promises me that I'm going to be back again this year. But we have one MEO mission with 4 satellites, and we have the SES-12 mission, and we have 2 other contracts which we are in the final stages of work at the moment with Arianespace. So hopefully we have a lot more missions to do here, a lot more satellites to launch. 40 out of 40, perfect mission. I have nothing more to say, but thanks very much to everybody who is involved with this. We are most grateful to your support, and we look forward to working with you again in the very, very near future. Thank you very much, everybody.
Thank you. Boy, what a great time of the mission, huh? February 2014. That was the month in the year that the journey began, where SES put their trust in the Boeing company to deliver the SES-15 satellite. Today, we took a huge step forward. We completed the satellite 5 days ahead of the schedule, less than 25 months from contract signing, and today, launching it and separating from the vehicle in a great ride. And we're taking another step towards delivery and that promise and that commitment to that capability. I want to start by thanking Luce and Martin and the collective teams, because this program from the beginning has been about teamwork. Jim Paterka, Holly Murphy, the Boeing leadership team, as well as the SES and Ariane teams, just working collaboratively together to make this program a success. So I really have to start by thanking those folks. As Ariane has mentioned, this is our 53rd launch. A very, very deep and rich and valued history, and our first Soyuz launch. And so we are looking forward to developing an equally long relationship with Soyuz as we go forward. Our SES relationship goes back over 25 years, back to the launch of Astra 1C in 1990. SES-15 is our 12th satellite, and as you have heard, the first all-electric satellite for SES. This will be our 5th all-electric satellite, and we're very proud to say we're the only ones that have delivered, launched, and are operating all-electric satellites. So we are really, really excited to get this capability to SES, because all-electric means more payload and more capability for the customer. So very, very excited about that. So we look forward to our continuing relationship with SES, with Ariane, and with Soyuz, and just want to thank the collective teams. Just a super, super day, great ride, and we look forward to delivering the satellite ahead of schedule as we did the build. So thanks again to everyone.
So again, congratulations for this outstanding success. We will be back on June the 1st with our 3rd Ariane 5 mission of the year. It will perform a dual launch to put onto geostationary transfer orbit the telecommunications satellite VS17 for the US Viasat operator and the satellite Eutelsat 172B for the European operator Eutelsat. Then it will be followed by another dual Ariane 5 launch on June the 28th for our customers in Marsat Elasat and ISRO. Thank you for your attention and enjoy your evening.
So it's mission accomplished for all the teams, and huge congratulations to SES and the operational teams who are now taking on the job of flying their satellite. Congratulations to everybody at Boeing who worked so hard to build this innovative new spacecraft, and to all the men and women at the Guiana Space Center who helped to make today's launch happen. Soyuz has successfully done its job. So until next time, from me, Katie Haswell, goodbye.
Allumage et décollage.